Hello everyone. Today I'll be covering Huffman coding. So Huffman coding is a technique which is used to reduce the size of data or message. So like if we want to send a message to someone and the message is somewhat bigger in size, but we want to send it to the person. So we can reduce its size by various methods. So one such method is Huffman coding. So here I am having a message B C C A B B D D followed by many other characters, and in total it is 20 bits. So messages are sent using ASCII code. So what are ASCII codes? ASCII code is a unique character defining bits. So each character used to have a 8-bit code. 8-bit. By 8-bit I mean each character, like here we are having C. So it will have a 8-character unique ASCII code which will be used to send it. So there are 20 bits in total and each bit is having a 8-bit ASCII code. So the message size will be 20 into 8, 160. And we want to reduce this size. So we have various techniques to do so to reduce the size. And we'll be learning the same in this video. So we have two methods, fixed size code and variable size code. So before trying to know what fixed size code, let me tell you about the ASCII code. So usually ASCII code represents in total code 28 characters, but our message is of 5 characters. So we need now to have all those 8 bits to encode our message. So to represent them in a fixed size, what we'll do, we'll assign the fixed size according to our wish. So to represent one character, we usually have 2 to the power and ASCII bits. With 2 to the power n, what I mean, when we take n is equals to 1, we can represent 2 characters. We have 5 characters, so we do 2 to the power 2. With 2 to the power, we can represent 4 characters, but we have 5 characters. We will go one more time. With 2 to the power 3, we can represent 8 characters. And we can easily accumulate all our 5 characters using 3 bits. So how we represent this? Like for 2 characters, what we do is 0, 0, 0, 1, 1, 0, and 1, 1. And for 3 bits, it goes like this. So for A character, we can give it as 0, 0, 0. For B, we can give it as 0, 0, 1. For C, we can give it as 0, 1, 0. For D, we can give it as 0, 1, 1. And for E, we can give it as 1, 1, 1. So now we have represented all the characters using 3 bits. So I forgot to mention you about the table. What I have done is I have mentioned the count of frequency of each of the character. Like A has came for 3 times, B has came for 5 times, C has came for 6 times, D has came for 4 times, and E has came for 2 times. In total 20. So we have all the characters converted into the code of 3 bits. So what will be its size? It will be 20 into 3. 20 characters, 3-bit size, 20 into 3, in total 60. But our task is not done. Why so? When we will encode this message, it also need to be decoded. So how will the other person can decode it? Until unless we will provide them any chart or any table with which he can refer and decode it. So we need to provide the ASCII characters of this code and the sizes of these bits. So the ASCII character for those codes will be 8 into 5. Why so? 8 ASCII bits and 5 characters. 8 into 5 is 40. And the size for these bits will be 5 into 3. Why so? 5 number and 3 each bit. 5 into 3 is 15. So in total, the table mapping will be of 55. 55 and 60. That is 115. So our size has been reduced by 40%. Now comes the variable size code, which is the actual Huffman coding which we are going to cover in this video. So what Huffman says, we need not to assign a fixed size to our characters to encode it. In place of that, we can assign a small size code to a more occurring character and a large size code to a lesser character. What I mean with that, there are various characters with different count of frequencies. We can assign the small size code to say B and large size code to say E. What it will do? It will reduce the size of the message and which we want through Huffman coding. So now we will find the code of each of the character using the optimal word structure. So let me draw the tree. So in an optimal first pattern, we used to arrange our all characters in the increasing size of their frequency. So our least occurring character is E, then it is A, then comes D, then B, and then C. We will write the count. So, optimal merge pattern used to follow the 3D method. What it says, select any two minimum and take out the sum of them. So, we will select all the minimum pair and find the sum. So, here 2 and 3 is the minimum pair. Now 5, 4, 5, 6. We can select these two 5, 4 or these two 5, 4. We are selecting these two 5, 4. Now 9, 5, 6. So minimum pair is 5 and 6. Now last one pair, 9 and 11. So we have found the optimal merge pattern for our message. Now we will assign the code to it. For the left hand side we will assign 0 and for the right hand side we will assign 1. So 0, 0, 0, 1, 1, 1, 0. What we have done is we have assigned 1 over there. We have assigned 1 to our right hand characters and 0 to our left hand side. So now to find the code, what we will do, we will go from root to the particular character to know its code. So to know the code of E, we will go 0, 0, 0. Code of A, 0, 0, 1. Code of D, 0, 1. Code of B, 1, 0. Code of C, 1, 1. So that's how we have found the code of each of the characters in our message. Now we will calculate the size of our codes. So this code has occurred 3 times in our message. So it will be 3 into 3, that is 9. This 2 code has occurred 5 times. So 2 into 5, 10. This one 6 times. This one 4 times. This one 2 times. So this is in total 45 minutes. That is the size of our encoded message. But our task is not done. We need to send a chart or something for the other person to decode our message. So we need to send the ASCII code of our characters and the total size of our bits. So ASCII code for our characters will be the same, 8 the ASCII code and 5 characters. So 8 5s are 40. And in total these bits are 3, 6 and 6, 12. In total these are 12. It is 52. So our chart will be of 52 bits and in total 52 and 45 will be 97 bits. So our message has been reduced to a size of 97 bits, which was earlier 160 bits. How 160 bits? The character was of, the message was of 20 characters, and each character was having a ASCII code 8 bits. So 20 into 8 is 160 bits, and now our message is 97 bits. This is what Huffman coding does. The message has been reduced from 160 characters to 160 bits to 97 bits, almost 50 to 55% of reduction. So now comes the application part, which is the last part of the video. So the basic 2 applications of Huffman coding are, the first one is reduce the file size. So usually we have a lot of files in our system and we want to reduce the size. What we can do is we can encode them and restore them. So, and the next application which we have covered in much detail, to reduce the cost of transmission. What I mean by that is, what we did in our example, we had a message of 20 characters and we had encoded it and sent it to the other person. What that did is that reduced the cost of transmission because the message was encoded and was reduced in size. That is the major application of